everyone. Myself Ankit Sharma from Engineering College Ajmer, Department of Mechanical Engineering. Today I will discuss 4D printing technology. Let's we start our discussion. Before we start 4D printing technology, let's have a look toward the 3D printing technology definition. The 3D printing process builds a three-dimensional object from a computer-aided design CAD model, usually by successfully adding material layer by layer, which is why it is called additive manufacturing. The example of for 3D printing technology, jewelry molding, mask, toys, etc. 4D printing technology. Let's have a look toward the definition of 4D printing technology. The self-changing structure of 3D printed part after post-processing is called 4D printing process. 4D printing is the process through which a 3D printed object transforms itself into another structure over the influence of external energy input as temperature, light, or other environment stimulus. As we can see in the example here in zip file, the transformation of object as per the required external energy input. What does 4D stand for? The 4D, meaning the fourth common dimension, is an important idea in physics referring to three-dimensional space 3D, which adds the dimension of time to which other three-dimensional of length, width, and depth. Here we can say that the fourth dimension is dimension of time because we require here external energy which can change here its shape, size, and others. For any type of 3D printing, we require material, but in case of 4D printing, we require smart material. Let's we define the definition of smart material. Smart material are those materials that possess the ability to changing their physical properties in a specific manner in response of specific stimulus input. Here the inputs are pressure, temperature, electric and magnetic field, chemicals and nuclear radiations. The associable change physical properties could be shape, stiffness, viscosity and damping. In simple word, if we provide external energy as a pressure, temperature, electric, magnetic field and others, then we can show changes in their shape, stiffness, viscosity and others. Now we will take the example of smart materials and their types and their input force and their required output. The piezoelectric material, we required input mechanical stresses and the output is potential difference. In electrostatic materials, input is electric field and output is deformation. In magnetostructive material, input is magnetic field and output is deformation. In thermoelectric materials, input is thermal energy and output is deformation. In shape memory alloys, the input is thermal energy and output is deformation. In photochromatic materials, the input is radiation and output is color changing. In thermochromic, the input is thermal energy and output is color change. Here we saw that if we required any input as external energy, then we found output as their change in structure, size, colors, potential differences, etc. The here we can show in table the examples of these types of smart materials. Next, we define the definition of piezoelectric materials. Those materials capable of generating electric charge in response to applied mechanical stresses are piezoelectric materials. As we saw in previous slides, the input is mechanical stresses and output is potential difference. They carry significant properties such as electro and magnetotheological fluids. These fluids can change viscosity upon the application of external magnetic or electric field. Examples are human bones, crystal like quartz, ceramics, etc. Let's now we define shape memory polymers. Shape memory alloys got transformation under predefined shape from one to another when exposed to appropriate stimulus. As we can see in the figure, the Eiffel Tower changes shape as per the required heat. Whenever required, the polymer gain its final shape when external energy is applied. Here, the polymers required heat as a most activating agent. Now, we define the 4D printing processes. There are generally, or we can say mainly, four types of 4D printing processes. First is fabrication, second is joint and folding, angle strands, third is custom angle surface, and final is curved surface folding. Fabrication. The general definition of fabrication is a person who fabricate or manufacture something is called fabrication. In 3D printing, ultraviolet curvable polymers are deposited by printer and curves layer by layer using ultraviolet light, thereby creating a complete 3D structure. Printers are capable of printing multiple composite materials that various properties such as color pattern, material hardness, and transparency allowing creation of complex multiple composite parts in a single process. Digital materials can be printed with this process. 4D printed parts are generally composed of rigid plastic and digital material that react upon external energy sources. Here, digital materials are smart materials. The second one is joint and folding angle strand. 4D printing 4D joints include multiple layers of material composition of rigid polymer, expanding material and digital material depict the folding direction and their pattern. As you can see in GIF, the folding of objects. If the composite is placed above rigid polymer, the surface will fold downward, and if placed below, the surface will fold upward. The folding happens due to downward and upward force applied to rigid material. It is the main factor of folding. Custom angle surfaces. Similar process as folding. Folding occurring can be monitored with the help of codes producing custom angles and accommodation of date from calibration. After the digital model was sent to be printed, physical model was immersed in water. The water is as a external energy source. The transformation process occurred within certain time with the final desired model having edges aligned perfectly aligned with neighboring edges. The third one is and final one is surface curling. Curling is because of expansion force. The main factor behind this curling is expansion force. It is the similar as the folding process. The curling effect is much more visible with the increasing length and breadth of surfaces. Here we can see in the diagram placing expanding material over the top of rigid material give curved surface with similar radius toward the rigid surface. Similarly, placing expanding material below the rigid material result reserve effect. As we can see in the figure, there are two layers, upper layer and lower layer. Because of that, we can show surface curling. The application of 4D printings are medical research, aeronautics and robotics, military application, furniture and house appliance, fashions, automotive industries. SWOT analysis. A study undertaken by an organization to identify its internal strength and weakness as well as its external opportunities. Why we require SWOT SWOT analysis? Because we want to compare in 3D printing and 4D printing in next slides. SWOT analysis of 3D printing. Strengths of 3D printing: low cost, available for all, positive market growth, efficiency of manufacturing process, easy to build custom models, high product quality. The weakness of 3D printing: some machines are expensive, printing hours are longer, quality differ with printers used. Different printers produce different qualities, may need post processing, materials selection limitation, required control environment, learning to use of machine and software. We require learning of software and machines. Opportunities: customization of existing design, active material development, recycle plastic garbage, multicolor prints, multi-material prints, and add generation of 4D printing technology and introduction of advanced machine, high speed and resolution. Let's look toward the threats of 3D printing: machine complex compatibility and upgradation required, public safety, patent, copyright, trademark, software problem, ethical issues, intellectual properties rights, threats to traditional workforce. Now analyze the 4D printing technology with SWOT analysis. The strength in 4D printing: efficiency of material and manufacturing processes, positive market growth, multicolor print, multi-material print, time efficient, and smart materials based upon multi-material 3D printing. Now let's have look toward 4D printing technology's weakness: expensive smart material and limited smart material, expensive hardware, printer that may be restrict public from using it, accuracy in shape change, complex shape, required specialized personnel, and controllable environment. Opportunities in 4D printing: helps logistic problems, transportation, helps in extreme places, war zone, military spaces, space, useful for implement in medical field, concept of smart city, building and structure. These are the application of 4D printing and generation of 5D printing. Threats in 4D printing technology: machine compatibility, public safety, impact on environment, copyright, patent, trademark, intellectual property right, system vulnerable to software hack, privacy, ethical issues. Now we will comparatively analyze between 3D printing and 4D printing technology. Categories: 3D printing technology, 4D printing technology. First we will analyze 3D printing technology. After that we will analyze 4D printing technology. Printing repeats a 2D structure layer by layer from bottom to top. This is the printing method in 3D printing technology. And in 4D printing, printing is the extension of 3D printing. We require 3D printer in 3D printing and smart and multi-material 4D printer in 4D printing. Thermoplastics, ceramics, metals, paper, food, polymer, nanomaterials, and biomaterials as a materials in 3D printing, and smart materials, multi-materials, self-assemble, self-sensing material, shape memory, polymer, and advanced material in 4D printing. The 3D digital objects drawing or scanning as a design concept in 3D printing, and 3D digital object with deformation features. Feature is deformation in 4D printing. The requirement, the equipment required, material extrusion and selective laser in 3D printing, and modified nozzle, binder and selective laser in 4D printing. Product flexibility is very low in 3D printing, and in 4D printing is product flexibility is present. Product static structure in 3D printing and smart and dynamic structure in 4D printing. The equipment cost of 3D printing is very low as compared to 4D printing, and in 4D printing it is high. The application of 3D printing are engineering and design, consumer product, education, aerospace, medical, robotics, military and defense, industrial fashion goods and others, industrial goods, fashion and others in 3D printing. And for 4D printing applications are medicine, medicals, furniture, transportation, aerospace, biomedical devices, soft robotics and others. As per the SWOT analysis, we found the result. Comparing SWOT analysis of both 3D printing and 4D printing technology, it is clear that 3D printing technology has advanced a lot than 4D printing. 4D printing being new invention opened the door toward the endless opportunities in research field of printing. As per the rating table, we found that 3D printing is better than 4D printing. Now let's start the discussion. Challenging while adopting 4D printing as a 3D printing. Safety. 3D printed weapon can easily be fall into hands of criminals, children, mentally ill persons and convictive, which will arise the question regarding public safety and security. Intellectual properties. Anyone can buy 3D printer and print anything according to their wishes. Intellectual properties includes copyright, patent, trademarks, blueprints, design. No one wants that his design can be used by any other one and it take credit of that design. Now third one is material selection. We require smart material for 4D printing that are very expensive and not easily available. Second part of discussion is what separates 4D printing technology from 3D printing technology. Time factor. Here in 4D printing, the fourth dimension is time, and it takes lot of time to transform from initial shape to final shape. Second one is materials. In 3D printing, materials are easily available in market, but in 4D printing, we use a smart material that are not easily available in market. Hardware 3D printing machines are available in market, but 4D printing machines are under research. Software CAD CAM, SolidWorks are other modeling software for 3D printing, but we required simulation software for 4D. Simple manufacturing. The products are directly built from standardized digital file and all the computer control process help reducing time for expertise as well as human interaction required to create objects. In 3D printing, we required human interaction to create object. In case of 4D printing, simple looking structure can be printed and then with the help of external activities, activating agents can transform into complex, large functional structure, mass production and customization. 3D printing technology enable effective design and manufacture of personalized product. Personalized customization items with normal price can be particularly positive steps for 4D printing. Under user responsive product, environmentally adaptive structure, weather adjusting product, spare parts, and printable customer electronics prove superiority of 4D printing over 3D printing. In general word, customization in 4D printing easily as compared to 3D printing. Now let's we look toward the conclusion. What we learn from these slides. 3D and 4D printing technologies are advanced technologies. 3D printing technology use produce static structure in three coordinates or we can say in three directions, three dimensional. And 4D printing is the combination of smart materials, smart materials arts and 3D printing technology. 4D printing has emerged and gained attention according to the structure response over time under environment stimuli. 3D and 4D printing technologies are comparatively analyzed using SWOT method, which presents its strength, weakness, opportunity, and threats. Thanks for being with us. Thank you.